Hello everyone, it's me, Sanjay Vasu, back again for another video. This time I'll be doing it on Cambridge IGCSE Additional Mathematics, Paper 1, which is the non-calculated paper, and this is a specimen paper for examination from 2025. In this video, I'll be doing questions 6 to 10 of this paper. Let's start. Question 6. A. F of x equals 3e to the power of 2x plus 1 for x in all real numbers. G of x equals x plus 1 for x in real numbers as well. 1. Write down the range of f and the range of g. Let's start with f of x. So the range of f is going to be a set of values which f can take after we do the function. So what are the set of values that 3e to the power 2x plus 1 can take? So to find that, we know that e to the power of x can always be greater than 0. Always has to be greater than 0. So e to the power of 2x also has to be greater than 0. So if e to the power of 2x is greater than 0, then 3e to the power of 2x is also greater than 0. And that means 3 to the power of 2x plus 1 is going to be greater than 1 by adding 1 to both sides. So f of x is going to be greater than 1. This is our range of f. Now the range of g. The range of g is the output values of g, or after you do the function x plus 1, what are the values that you can get? Well, you could get any value in the real plane actually, when x is a real number. So even if you use some really small negative number, like some minus 1 million, this thing can take on minus 9999999 also, this value of g of x. Or it can even go all the way down to minus infinity. It'll still be defined. So x has to be a real number and g of x can take any value inside the real plane. So that's our answer. Part 2. Find g squared of 0. G squared of 0 is just g of 0. And that's going to be equal to g of 0 plus 1. G of 1. And g of 1 is going to be equal to 1 plus 1, 2. That'll be our answer. Part 3. Hence find f g squared of 0. Since we know what g squared of 0 is, we can just do f of g squared of 0. And using the value which we found, which is 2, we can just say that this is f of 2. Using part 2. And that's going to be 3e to the power of 2 times 2 plus 1. 3e to the power of 4 plus 1. And we can leave our answer just like this, because we cannot use a calculator to simplify this value. That'll be our answer. Now let's go to part 4. On the axis below, sketch the graphs of y equals f of x and y equals f inverse of x. State the intercepts with the coordinate axes and the equations of any asymptotes. First thing, we can sketch the graph of y equals f of x, because once we've done that, sketching y equals f inverse of x is very easy. So firstly, we need the intercepts with the coordinate axes. So first, let's find the y-intercept. That means x equals 0. So y is equal to f of 0. And this f function is just 3e to the power of 2x plus 1. So let's just write that, 3e to the power of 2x plus 1. And now substituting x equals 0, we get 3e to the power of 0 plus 1, which is just 3 plus 1, 4. So when x is 0, y is 4. So it'll be over here, 0, 4. Now we need to find the x-intercept. That means y is equal to 0. So if this is equal to 0, then 3e to the power of 2x is minus 1. E to the power of 2x is minus 1 by 3. And now taking the ln on both sides, 2x equals ln of negative 1 by 3. And that means, wait, this does not exist. Ln of any negative number does not exist. Since e to the power of something, in this case, let's just say it's 2x, cannot be equal to 1 by 3. Negative 1 by 3, sorry. It cannot even be a negative number. The minimum it could be always is greater than 0. So some number a to the power of another number, let's say x, is always greater than 0. Therefore, it has an asymptote somewhere. So this graph has an asymptote parallel to the x-axis. But where is this asymptote? What exactly is the line? We need to find that, since the equation of any asymptote should be stated as well. Well, what is the borderline value for e to the power of 2x? So the range of e to the power of 2x is that it's greater than 0 at all times. No matter if x is positive or negative or any value, it's greater than 0, of course. And because it's greater than 0, that means 3e to the power of 2x is also greater than 0. And 3e to the power of 2x plus 1, which is our equation here, is greater than 1 at all times. So the asymptote is going to be y equals 1. The horizontal line, y equals 1. So this will be our asymptote, y equals 1. Of course, as the x value gets smaller and smaller, the y will approach 1. But it can never be equal to 1, since e to the power 2x is not equal to 0, it's greater than 0. Strictly greater than, which means it cannot be equal to 0. So, as x approaches negative infinity, y approaches 1. That's the meaning of this asymptote. So we can just draw the graph, something like this. Now that's our answer for y equals f of x. Now what about f inverse of x? Well, we don't really need to find f inverse of x since we know what f of x is. I mean, we know the shape of the graph, we know everything about it. We can just reflect it along the line y equals x, this diagonal line stretching from the bottom left to the top right of any diagram. So if we reflect this graph, first we'll reflect this point over here to the point 4, 0 on the x-axis. And indeed, if you found the x-intercept of y equals f inverse of x, it would be 4. And well, if you deflect this asymptote y equals 1 along this line, you will get the line x equals 1, of course, since any y values are just changed to x here. So x equals 1. And that is our asymptote for y equals f inverse of x. And by reflecting this graph shape, we'll get a graph shape something like this. So if you have to draw it through 4, 0, it will go like this. I'll just readjust this point a bit. Well, that will be our answer. And yes, I forgot to label this as x equals 1. But we have the asymptotes, the two asymptotes, and we have the coordinates of where these graphs touch the coordinate axis, which is x and y axis. And of course, we do not really need this line. I just drew it for some clarity on where we need to reflect this graph of f of x to get f inverse. Actually, it's better if we keep this dotted line of y equals x, because the examiners need to know that we've reflected this graph to get the graph of f inverse of x, because we can see that the intercepts are just reflections along this diagonal here. So therefore, we can just leave this diagonal line to show that we've got this graph from this one. That's our answer. B. It is given that h of x equals a plus b by x squared, where a and b are constants. This is very important, keep this in mind. 1. Explain why negative 2 less than equal to x less than equal to 2 is not a suitable domain for h of x. Well, where are the x terms in this function? It's b by x squared, this term over here. So it is b, which is a constant, times 1 by x squared. And this 1 by x squared cannot take on the value of x equals 0. That's the only value which it cannot entertain, because 1 by 0 squared is just 1 by 0, which is undefined. You cannot divide anything by 0. But then this domain, given the question, has the value x equals 0 inside it. 0 is greater than or equal to minus 2 and less than or equal to 2, right? So this domain is not suitable, since x equals 0 is not a valid value for h of x. But then this domain contains x equals 0, and therefore this is not a suitable domain. Part 2. Given that h of 1 equals 4 and h prime of 1 is 16, find the values of a and b. So h of 1 equals 4. That means a plus b by 1 squared is equal to 4. And that means simply a plus b is equal to 4. So that is our first equation. Now, for h prime of 1, we need to find h prime of x. So h prime of x is the derivative of h with respect to x. So dh by dx, in other words. So if we're taking derivative with respect to x, these a and b are just constants, right? So when you take the derivative, this a completely disappears. The derivative of a is just 0 here, since it does not have any x value connected with it. So it's just 0 plus the derivative of b by x squared. So b by x squared is just bx to the power minus 2. Taking the derivative, we just use the normal derivative formula, ax to the power of n. The d by dx of this is going to be n ax to the power of n minus 1. So in this case, it will be minus 2 bx to the power of minus 3, which is minus 2, since the minus 2 cancels, so minus 2b by x cubed. The plus cancels because the negative of minus 2. So we can just remove the 0 and we get this as h prime of x. Now h prime of 1 is just going to be minus 2b, because x cubed is 1 cubed, which is just 1. So negative 2b is equal to 16. And therefore b equals negative 8. Now we know what b is, so we can just substitute this into a plus b equals 4. So a plus negative 8 is 4. And therefore a is equal to 12. And this will be our answer. Now I can go to question 7. In arithmetic progression, the fifth term is equal to 1/3 of the 16th term. The sum of the fifth and 16th term is equal to 33. Find the sum of the first 10 terms of this progression. Well, if the fifth term is equal to 1 by 3 of the 16th term, we can use our trusty a plus n minus 1 times d formula for an arithmetic progression. I have the fifth term, which means, let's say this is the sequence. So the fifth term is a plus 4d, because n is equal to 5. So it's going to be equal to 1 by 3 of the 16th term, so a plus 15d. And in other words, when we simplify this, 2 by 3a minus d is equal to 0. Now this we can write as equation number 1. Well, we'll have one more equation using this. The sum of the fifth and 16th term is equal to 33. So a plus 4d plus the 16th term here, a plus 15d, is equal to 33. And that means 2a plus 19d is equal to 33. That's equation 2. Now we have two separate equations. Let's just multiply the first one by 3. I'll tell you why. So 1 times 3, so equation 1 times 3, so 2a minus 3d, once again is 0. We just multiply by 3 on both sides. This 3 times 0 is still 0, and multiplying by 3 here will give this. Now we have a 2a here and in the second equation. So let's just label this equation as 3, and we can write the second equation right below it. Now, when we do 3 minus 2, we can cancel out the a's. The two a's will cancel, and then negative 22d is equal to negative 33, and d is equal to 3 by 2. Now we know what d is. We can find a. So we can substitute this into equation 1. 2 by 3a minus 3 by 2 is equal to 0. 2 by 3a is equal to 3 by 2. And a is equal to 9 by 4. Now we know that it is a 9 by 4 plus 3 by 2 times n minus 1. This is the sequence. And we can simplify this as 3 by 2n plus 3 by 4. Let me just move this up a little bit so I have some space for the next steps. Remember that this is not the end of the question. We have one more part left to do, which is to find the sum of the first 10 terms. Now, to find the first 10 terms, we first need to know what is the sum of an arithmetic progression normally for any value of n. Here we go. This is a formula which is given in the formula sheet at the front of the paper. The sum for any value of n, which is for any value from 1 to n, so that sum is going to be half times n times 2a plus n minus 1d. And for s of 10, we can just do this using our values over here. So s of 10 is equal to half times 10 times 2a, which is 2 times 9 by 4, 9 by 2, plus n minus 1, which is 10 minus 1, 9, times, what is d? As we know here, 3 by 2. That's going to be 5, which is half times 10, multiplied by this value over here. Sorry, I forgot to close the braces. So this value over here, 9 by 2 plus 9 times 3 by 2, that's going to be 18, which is simply 90. That's our answer, 90. Let's go to part B. In a geometric progression, the sum of the first two terms is 16. The sum to infinity is equal to 25. Find the possible values of the first term. Well, let's do the sum of first two terms. But before we can do that, of course, we need to know the formula for a geometric progression. First, we know the general formula for a geometric progression. It's AR to the power of n minus 1, where R is the geometric ratio, or the thing we multiply by every time we go from one term to the next. And A is the first term. So, the sum of the first two terms is just going to be A plus AR. That's going to be 16, because AR to the power of 1 minus 1 is just A. That's the first term. Now, 2 minus 1, this will become AR, second term. The sum is 16. Now, what's the sum to infinity of a geometric progression? That's going to be A by 1 minus R, right? So that's going to be 25. And that means A is equal to 25 times 1 minus R. And this over here can be written as A times 1 plus R is equal to 16. So now we have two equations, once again. First one, second one. So we can substitute, this time substitution, 2 into 1. So we know that A is equal to 25 times 1 minus R. So 25 times 1 minus R can be substituted here. 25 times 1 minus R times 1 plus R is equal to 16. So that means when we simplify this factorization, 25 minus 25R squared is equal to 16. So 25R squared minus 9 is equal to 0. And factorizing this, we get 5R plus 3 times 5R minus 3. Since this is in the form of A squared minus B squared, where A is just 5R and B is 3. And A squared minus B squared is the difference of squares, which is A plus B times A minus B. And now, if this is equal to 0, we need to make sure that each bracket is equal to 0, and each of them will give two different solutions. So r is equal to plus or minus 3 by 5. But we don't want the value of r. The question asks for the possible values of the first term, which is, as we know, a. Since we have r, we can just substitute this two values into any one of these equations. I'm going to substitute it into this one, the second one. And we can just get the value of a, derive it from these equations. So when r is equal to positive 3 by 5, the a value is going to be 25 times 1 minus 3 by 5, which is just 25 times 2 by 5, 10. So this is one value, and when r is equal to minus 3 by 5, a is equal to 25 times 1 plus 3 by 5, because two negatives make a positive. So 25 times 8 by 5, which is just 40. And these two are the correct answers. Now we can go to question 8. Given that the integral from 1 to a of 2 by 2x plus 3 plus 3 by 3x plus 1 minus 1 by x dx equals the natural log of 2.4, where a is greater than 1. Find the value of a. Well, we have been given a definite integral of a few different terms, and they are either added or subtracted, so we can separate these integrals. So this is going to be equivalent to the integral from 1 to a of 2 by 2x plus 3 plus the integral from 1 to a of 3 by 3x minus 1 minus the integral from 1 to a of 1 by x. Of course, all of them to dx. And now how do we take these integrals? We can use something called the method of substitution. How do we do that, you may ask? Well, we have a function here which is inside of the integral, 2x plus 3. Now, its derivative with respect to x is just 2 dx. So if there's a function and its derivative separately inside the same integral, we can use the substitution method. So we can take u is equal to 2x plus 3 and du is equal to 2 dx, since du by dx is 2. We're just writing it differently since we have a dx over here times 2. So the integral from 1 to a of 1 by u du, since 2 dx will become du, and 2x plus 3 is u, so 1 by 2x plus 3 is just 1 by u. Now, we can take another function, v. Of course, these are temporary substitutions, so you can just do them and then divide them later. So v is going to be 3x minus 1 here. Why? That's because the derivative of this, dv by dx, is equal to 3. So dv is just 3 times dx. When we just bring this divide by dx to the other side, we multiply, and that's why we get that. So we get this is equal to dv, so it'll be 1 by 3x minus 1 left, and that's just 1 by v. So we get another similar integral, 1 by v dv, and then minus the integral from 1 to a of 1 by x dx. And why am I not converting this into a u substitution? Since the only function there is x, and if you write u is equal to x, then du is equal to dx, and that won't really change anything since it just becomes 1 by u du, which is the same thing as 1 by x dx. It's just written with a different variable. So there's no need to do this. This is a standard integral. And the reason we've converted these two into this is because these two are also standard integrals now. So the integral of 1 by u, 1 by v, 1 by x, they're all just ln of u, of course the absolute value of u, since the value here cannot be negative. If it was negative, this is undefined, that's why we have absolute value. So plus ln of v minus ln of x. And now all this from 1 to a. And of course, this is from x equals 1 to a. We can't just substitute a and 1 here inside directly. So that's to be x equals, and therefore we write these u and v in the terms of x again. We just unsubstitute them. So ln of 2x plus 3 from 1 to a plus ln of 3x minus 1 from 1 to a minus ln of x from 1 to a. Now we know the fundamental theorem of calculus that states that if you have an integral, a definite integral from a number a to b of some function f of x dx, this will be f, capital F of b minus capital F of a, where capital F of x is just the integral of small f of x, or f prime of x equals small f of x. So using the same principle, we just write this as ln of 2a plus 3 minus ln of 5, since ln of 2 times 1 plus 3 is just ln of 5, and then plus ln of 3a minus 1 minus ln of 2, and then minus of ln of a minus ln of 1. So that is going to be minus ln a plus ln 1. And ln 1 is just 0, so we can just cancel this out completely. And this whole thing is going to be equal to ln of 2.4. And why have I removed these absolute values here? You might have been asking this for a bit. That's because we know that a is greater than 1. So if a is greater than 1, all these will be positive, right? 2a plus 3 will be greater than 5, and 3a minus 1 will be greater than 2. And of course, this will be greater than 0. So now we can just use logarithmic laws to simplify this. So ln of 2a plus 3 times 3a minus 1 divided by a times 5 times 2 is equal to ln of 2.4, using the fact that ln a plus ln b is equal to ln of ab, and ln a minus ln b is equal to ln of a by b. You will get all this. So we can remove the lns now. 2a plus 3 times 3a minus 1 divided by 10a is equal to 2.4. Now we can simply expand everything to get 6a squared plus 7a minus 3 is equal to 24a. And we can write this as 6a squared minus 17a minus 3 is equal to 0. And if you simplify this correctly, 6a plus 1 times a minus 3, sorry, not 1, 3 is equal to 0. And that means a is equal to minus 1 by 6, or a is equal to 3, right? But this is not our final answer. We know that a has to be greater than 1. Otherwise, these logarithms are undefined. This one would be undefined. This one would be undefined, since ln of negative 1.5 does not exist. So we have to have only a equals 3. So we can write, since a is greater than 1, a is equal to 3. So that will be our final answer. Now let's go to part B. 1. Find d by dx of 6 sine cubed of kx, where k is a constant. So sine cubed of kx is just sine of kx the whole cubed. So that's going to be d by dx of 6 times sine of kx the whole cubed. Now we can make another u substitution. Another substitution method, but this time for derivatives. So let's just write u is equal to sine of kx. So that means d by du of 6u cubed. But then we also have to multiply this by du by dx, or the derivative of this. This is our chain rule for derivatives. And du by dx here is going to just be k times cosine of kx. This is a standard derivative. So we can write this as this derivative 18u squared times du by dx. And this is simply 18 times sine of kx squared times k times cosine of kx. And of course, this k we can just write the front, 18k times sine of kx the whole squared times cosine of kx, and this will simply become 18k times sine squared of kx cosine kx. And this will be our final answer. Now for part 2. Hence, find the integral of sine squared of 2x cosine 2x dx. Well, this function here, let's just say this function is f of x. It is suspiciously similar to what we have over here. Just substitute k equals 2 and we'll get an almost exact version of the same function. So when k is equal to 2, this d by dx of 6 sine cubed of kx is going to be equal to 36 sine squared of 2x times cosine of 2x. And the integral we have here is everything here except we don't have this 36. So let's just say this is f of x. Take this as f of x instead. I'll tell you why. So this over here, the integral from sine squared 2x cosine 2x dx. That's going to be the integral of 1 by 36 of f of x dx, right? And that's the same thing as 1 by 36 times the integral of f of x dx. Why? That's because f of x is a constant. F of x is something which involves x, but 1 by 36 does not involve any x. It's a constant. Therefore, we can bring it outside as long as we multiply. So if you multiply inside the integral by a constant, we can just bring this constant outside and multiply it. And therefore, since we know the integral of f of x, we know that the integral of this is just this function here, where k is equal to 2. So that means this will be equal to 1 by 36 times capital F of x, or in other words, the integral of this, which we already have, 6 times sine kx the whole cubed. 6 times sine of kx the whole cubed plus c, because this c is the constant of integration. If you differentiate this c will just become 0, so it won't affect the answer of differentiating the integral. That's why we add a c, because we do not know what that constant is. That's simply going to be sine of kx the whole cubed divided by 6 plus c, because 1 by 36 times 6 is just 6 by 36, and we can cancel 1 by 6. 1 by 6 times this plus c is our final answer. Now we can go to question 9. In this question, the units are meters and seconds. A particle P is traveling in a straight line. Its acceleration, a, away from a fixed point O, is given by a equals 3t plus 2 whole to the power of minus 1 by 3, and of course this is at any time t, where t is greater than or equal to 0. A. Find an expression for the velocity of p at time t. Well, we have the acceleration function, so of course, we're going to find the velocity. It's just going to be the integral of the acceleration. So that's going to be the integral of a dt. And this a is a function of t. So 3t plus 2 whole to the power of minus 1 by 3 dt. Now the integral of some function to the power of n, so let's say it's u to the power of n, where u is equal to some function of x. So that means the integral will be u to the power of n plus 1 divided by n plus 1, and then divided by the derivative of this function u. This is a kind of form of the chain rule, just reverse to show our integration. Chain rule is usually a rule which is done in differentiation. Therefore, for integration, we have a completely separate version of the rule, or in other words, the rule of substitution, where you just have a function u is equal to some f of x, and that is what we're doing here. So using that formula which I just shared, it's going to be 3t plus 2 to the power of 2 by 3, because that's negative 1 by 3 plus 1, and then divided by 2 by 3, and of course divided by du, which is 3. And one thing you need to remember is that you need a constant c, the constant of integration. So that's going to be half times 3t plus 2 to the power of 2 by 3 plus c. Now we need to find the c value. Well, we know that when t equals 2, p is traveling with a velocity of 8. So we can just use this information and substitute it into this equation. So when t equals 2, this velocity, I'm just writing it as v of t. So v of 2 is going to be equal to half times 8 to the power of 2 by 3. Since 3 times 2 plus 2 is just 8. And of course, plus c. And that's just 8. So 8 to the power of 2 by 3 is the cube root of 8, the whole squared. And that is going to be 4, since cube root of 8 is 2. And 4 times half is just 2. So 2 plus c is 8, and c is equal to 6. Therefore, the function v of t, I'll just write c equals 6 over here. So the function v of t is going to be equal to half times 3t plus 2 to the power of 2 by 3 plus 6. B. Explain why p is never at rest. So if p is at rest, that means its velocity is equal to 0. If p is never at rest, that means the velocity cannot be equal to 0. So the question is indirectly asking to prove that this can never be equal to 0. Well, the simplest way to think about this is that this to the power of 2 by 3 is just half times cube root of 3t plus 2 squared. And this is going to be always positive. So in the function v of t, which is equal to half times the cube root of 3t plus 2 squared plus 6, 3t plus 2, the whole squared, is always greater than 0 for t greater than or equal to 0. So, since this function, 3t plus 2 whole squared, is greater than 0, then v of t is greater than 6 for all t greater than or equal to 0, and p never has velocity equal to 0, and therefore p is never at rest. That's our answer. Now you can go to part C. Find the displacement of p from O when t equals 25 by 3. Well, the displacement is just the integral of the velocity. So now we just take the integral of this velocity function. So displacement, we just write that as s of t, that's going to be equal to the integral of v of t dt. You might think I should write d of t. I mean, this is also fine, but usually displacement is represented with s and distance is represented as d. So the displacement of p from O is going to be the integral of this function which we found, half times 3t plus 2, the whole to the 2 by 3 plus 6. And now this is going to be equal to, using the same rule we just did previously, half times 3t plus 2 to the power of 5 by 3 divided by 5 by 3 and divided, of course, by 3 once again. And of course, we have to add 6t because the integral of 6 is just 6t. And then a constant c as well. So that's going to be equal to, when the dust clears, 1 by 10 times 3t plus 2 to the power of 5 by 3 plus 6t plus c. Now this is s of t. Now using the information that it has a displacement of -negative 4.8 from O when t is equal to 2, so we can find out what this value of c is. So when s of 2 is equal to 1 by 10 times 3 times 2 plus 2, which is just 8, to the power of 5 by 3, plus 6 times 2 plus c, negative 4.8. And that means c is equal to negative 4.8 minus 12, which is 6 times 2, minus this value. So 8 to the power of 5 by 3 is just cube root of 8 whole to the power of 5. 2 to the 5 is just 32. Now 1 by 10 of this is 3.2. Subtracting 3.2, we get negative 20. Now the displacement when t is equal to 25 by 3 is just going to be s of 25 by 3, which is equal to 1 by 10 times 3 times 25 by 3 plus 2 whole to the power of 5 by 3 plus 6 times 25 by 3 minus 20. And that's just going to be, this will become 25. 25 plus 2 is 27. Now 27 to the power of 5 by 3 is just cube root of 27 whole to the 5. So that is going to be 3 to the power of 5, which is 243. Now 1 by 10 of this is 24.3. And then add 6 times 25 by 3, which is 50, and then subtract 20. We'll get our answer as 54.3. Now I can go to question 10. A circle has center 2, negative 4 and radius 3. The line y equals 2x minus 3 intersects the circle at points A and B. The perpendicular bisector of the line AB intersects at points x and y to the circle. Find the area of the kite AXBY. Firstly, let's find the intersection of the line y equals 2x minus 3 and this circle. First, we need to find the equation of this circle. So we have the center and we have the radius. So we know that the circle will have the equation of x minus the x coordinate of the center whole squared plus y minus the y coordinate of the center whole squared is equal to the radius squared. So this can be written as y plus 4 the whole squared, and that's just 9. This is our equation 1 for a circle. And now y equals 2x minus 3 is our second equation, which is the line equation. So the intersection of these two we need to find, and x minus 2 the whole squared plus 2x minus 3 plus 4, or in other words 2x plus 1 the whole squared is equal to 9 by substituting this into this here. So x squared minus 4x plus 4 plus 4x squared plus 4x plus 1 is equal to 9. 5x squared plus 5 is equal to 9. So 5x squared equals 4, x squared is 4 by 5, and x is equal to plus or minus root of 4 by 5. Now the intersection is when x equals plus or minus root 4 by 5. So when x is positive 4 by 5, square root of 4 by 5, then the y value we can find using our equation here. So 2 times the root of 4 by 5 minus 3. And we can just leave it like this. Since we cannot really simplify this, it's in third form. Now when x is negative of root 4 by 5, then y is just going to be minus 2 times root 4 by 5 minus 3. And we can also leave this inserted form since we cannot really simplify. This is the root of 4 by 5 like this. And now we found our intersection of this point A, this point B. Yes, these are the y coordinates. So this will be x of B, x of A. Alright, now we actually know what line AB is, since the points A and B are just on this line, y equals 2x minus 3. So that is going to be the line AB. And now the perpendicular bisector of AB we can find by finding the midpoint of AB. And of course, we need to find the gradient. So the midpoint of AB, let's do that first. That's going to be x1 plus x2 by 2, comma y1 plus y2 by 2. And adding the x values, we just get 0. So 0 by 2 is just 0. And adding the y values, these two surds will cancel out nicely, and we'll get minus 6. So minus 6 divided by 2 is just minus 3. And this will be our midpoint of AB. Now we can find the gradient. I'll move to a new page. So the gradient of the perpendicular bisector of AB, that's going to be minus 1 divided by the gradient of AB itself, minus 1 divided by 2, since the gradient of AB is 2. And now using that midpoint which we found, minus 3 is equal to minus 1 by 2 times 0 plus c, so c equals minus 3. And therefore, y is equal to minus 1 by 2 x minus 3. Now this line intersects the circle at the points x and y. So this is our third equation, and the circle equation is equation 1. So we can substitute this y equals minus half x minus 3 into the circle equation. So x minus 2 the whole squared plus minus half x minus 3 plus 4 the whole squared is equal to 9. And this is just minus half x plus 1 the whole squared. And that means x squared minus 4x plus 4 plus 1 by 4x squared minus x plus 1 is equal to 9. So when we do this, 5 by 4 x squared minus 5x minus 4 is equal to 0. 5x squared minus 20x minus 16 is equal to 0. Now we can use the quadratic formula to solve this. X is equal to minus b plus or minus root of b squared minus 4ac by 2a. That's going to be 20 plus or minus root of b squared, which is minus 20 squared, 400, minus 4 times 5 times negative 16. And that's going to be root of 400 plus 320, which is root of 720, divided by 2a, which is divided by 10. So we can just leave this like this, or we can also write it as 2 plus or minus root 720 by 10 like that. And we can write this as the square root of 720 divided by 100, and this is inside the square root, so that's just the square root of 7.2. Now if the point x is 2 plus 7.2 square root, then the y value of the point x is going to be minus root 7.2 by 2 minus 4. And yes, I'll need one more extra page to do this. So if x of the point y is 2 minus root 7.2, then y of y, or the y value of point y, is going to be minus half times 2 minus root 7.2 minus 3, which is root 7.2 by 2 minus 4. Now the area of the kite, which is our final step. That is the product of the diagonal lengths. So if this kite is like this: A, B, X, and Y. They're already given it's AX, BY. So AB and XY are diagonals. And you can work that out by drawing a rough sketch of the diagram as well. So as I said, if you have a kite A, B, and X and Y here, so this diagonal times this diagonal is just going to be our area. So we need to find the length of AB and the length of XY. I'll do AB first. So root of x2 minus x1, the whole squared, which is, let's just say, x of b minus x of a, the whole squared, plus y of b minus y of a, the whole squared. So x of b, we found the point b, which is in the x value minus root of 4 by 5, and the x value of a is just root of 4 by 5. So subtracting the two, we get minus 2 root 4 by 5, whole root of 4 by 5 squared, plus, sorry, this is inside, and plus y of b minus y of a whole squared. So y of b is as this, y of a is this. Subtracting the two, we get minus 4 of root 4 by 5. So minus 4 root 4 by 5 whole squared, and that's just going to be 16 by 5 plus 64 by 5, and the square root of this, that's the square root of 80 by 5, or the square root of 16, which is 4. Yep, you were worrying if there were going to be some really wacky values, some kind of surd values for this. Yep, we got a nice value here, 4. Even though we are working with surds, we got a nice little value there. Now, we need to find the length of xy. That's going to be, using the same formula, x of x minus x of y minus x of x, the whole squared. So x of x is 2 plus 7.2, x of y is 2 minus 7.2. Now 2 minus 7.2 minus 2 plus 7.2 is just negative 2 times 7.2. Sorry, root of 7.2 all of these. So negative 2 times root 7.2, the whole squared, and then plus the y values difference. So y of y minus y of x, which is here, that's just 2 root of 7.2 by 2 the whole squared, so that is root 7.2 the whole squared. And that's just going to be root of 28.8 plus 7.2. That's the square root of 36, which is 6. We're getting another nice value here. So now the area of the kite, AXBY, that's going to be half times the length of both diagonals. So in this case, the length of both diagonals is going to be XY and AB, which is 4 and 6. So multiplying by 6 and 4, we get the answer as 12. This is our final answer. With that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.